All right. Well, thanks guys for joining us this afternoon. I'm assuming everybody else is going to pop in as we get going. So resources bit.ly/Ty Cyberbot. And we are already on webinar 2. And I am so impressed by everybody's work in the programming assignment. It's been really fun. And it's also been really fun to read what everybody's saying in terms of challenges and how their kids are responding. And so I'm loving that. So we have more people that have done the work than are here. So we'll just kind of roll through and touch on people's questions if they're not here. If you are here, please do plan on sharing because we'll have you do that. So Chuck, you may be on if I have questions or concerns that I can't answer, okay? All right, Dan, do you want to start since you're at the top of the list?
Sure. Well, I'm now starting the program with a second group of robotics students, and in my class we use the MCL method of learning. And so a lot of times my students, we will establish goals on an individual basis, and then they'll meet those goals, and then they can advance at their own pace. So I get a variety of different levels of student skill sets. This has been absolutely amazing for my students on a couple of different levels, but specifically for the ones who have never touched anything as far as robotics or programming is concerned, to the level of those who have never done anything with electrical work or with breadboards or anything of that matter. So it has been amazing, and the kids are into it because they can actually see their work and see the result of their work. And then because they did the research, they did the reading, of course I'm there to help as needed, they own that knowledge. And this has been, it's been really a very positive thing in my classroom, a very helpful thing.
That's great.
That's really exciting, actually. I mean, and especially the ownership. That's awesome.
Let me ask real quick, Dan, had you done any text-based programming before bringing the Cyberbot into the classroom?
Very little.
Mm-hmm.
We've done some, but nothing to this level.
And they're taken to the Python okay?
Yes, absolutely.
Yeah, it's very approachable, I found.
It is. What's happening is that they more or less graduate from that onto more difficult things.
That's great.
So it's been a wonderful thing.
Cool.
That is really exciting. I'm glad to hear that. All right, let's see. Moving on down the list. Kayla, you're up. Do you want me to pull up your make code?
If you want to, you can. It's really simple.
We didn't ask you guys to do world peace or anything. So, mine is really simple too. I did it the other day because I was like, okay, I want to make sure I can do it too. And so I played around and it was fun.
Yeah, I teach 6th, 7th, and 8th. So when I made this program, it would be something that I would do probably with my 6th and 7th graders when they're just starting to code on the microbits, just because it's really simple. They're only using a few blocks, and it's something that I think that they could feel success in. Oh.
Look at that. It looks like a beating heart.
Yeah.
Super fun. Awesome. All right. So
I got to say, Kayla, that's fantastic. I've done the animation in Python, but I've never seen it in the make code. And to see how they can set brightness with a block, I mean, it only makes sense, but it's
pretty user friendly for the kids. I've done more microbit stuff with my kids, and they're kind of a little overwhelmed at first because there's so much more options on there. Instead of like code.org where they only give you just certain blocks and that's all you can use. In microbit, they give them all to the kids at the same time. So it allows for the a little more flexibility with the kids that have more programming. They can build something more complex, or the kids that have never coded can do something really simple.
Yeah.
So
Do your kids ever talk about the Java connection, the fact that they can see it convert instantly and then they can make changes in Java and see it in block?
I show them that. I have very few kids in 6th and 7th that will go in and play with the Java just because
It's intimidating.
I haven't really taught JavaScript. Like we do Python and we do HTML are the two the code text languages that I do. So I haven't personally done a lot with JavaScript, but I am hoping this semester to do a unit with my 7th graders where they do block coding and then do some Python or JavaScript programming.
Well, if they're looking at Java already, that's a no-brainer. We have content that is written in both block and Java. So I mean Python. So yeah, present them a lesson in block and then give them another one in Python. That's very good. Nicely done.
Cool. So what else have you been working on, Kayla?
Well, I still do coding at all 3 grade levels. My 8th graders right now are about to start. It's probably a 4-week long project on HTML coding, and it's through CS Discoveries on code.org, but that's the template base that I use. And then I use other resources like the W3H schools with the kids, and they end up learning like 10 or 12 tags by the end, but they research the information first, and then they make like a title page. They have to make like a list. They have to use all the heading tags. So they do, and they do image and they do hyperlinks too, or the other items that they do. So they'll be starting that next week. And so it's always fun to see the reactions at the end, because I always ask them, did you ever think you'd code your own website? And a lot of them said, not in a million years. So it's really cool to see those kids who never thought they would do something like that be successful at that.
So you shared a couple of resources that when you were trying to find Cyberbot lessons, and so I was going to pull those out for you to. So this is the CS for All Teachers latest content.
Maybe? Yep, and so that one, they actually, like I said, I came across this searching, but they have obviously all computer science related, but there's like discussions, they have webinars that they offer online, and then there's also like resources, and that's where I found the teaching cybersecurity lessons. And so they have them, you go to the other website I listed.
Okay.
That teaching security.org. Yep. This is more geared towards like high school, is what they said on their site, but there's bits and pieces that I think you could take for any age group. So they have these different types of lessons, and they're supposed to be like introductory to computer science schools. So if you scroll down, those are the 3 that they have right now out. So it was just something I came across. It didn't really relate to cyberbots, but it did have to teach with cybersecurity. So
Nice. Cool. Thank you for sharing.
Yep.
Awesome. All right. Let's see. Leanne, you're with us. Let's hear. I was so proud of you because you Googled, you solved it. And I love that. So I was like, and I'm glad you talked about it, because that's my secret behind the scenes. It's like I'll just Google that.
Well, and I don't have a whole lot of experience coding, so I basically had to. I mean, I knew the basic layout of the language from what we talked about at the session in town, but to get a series of basically shifting images, I had to figure out what to do with that. So I kind of just followed the layout that the website that I posted on there had.
Nice.
So
let's see if I can grab it or not. I don't know.
Yeah, so that's the microbit help page about the images, and then it's look at that.
Oh, it does exist. I didn't copy it very well.
So they give you the whole list of images, and then at the bottom they talk a little bit more about making your own images and then some animation stuff. But yeah, that's it. And then if you scroll through, so those are all the images that come pre-built with the microbit that you can call with Python. You can also drop down with the block. And then here they're showing you how to create your own images. So the 0, 5, and 9 are intensity levels. So 0 means that LED is off, 5 means it's half on, and 9 means it's full on. So if that first one, real quick, if you scroll back up, that first one right there, you can.
This one?
Yep. So, I mean, if you look at the 0s, the 5s, and the 9s, can you almost see the boat? Right. I think this is a really cool layout, that 5x5 grid, because it resembles a 5x5 LEDs. So one of our activities actually gives kids a 5x5 grid, and then they can create their own image there. And then I think it translates to this code really nicely. The next one they show just strings it all out into one line. And then animation just lists it. They talk about arrays here, and then you can actually go and make your images move from one to the next. So here's the ship as it sinks, and you can kind of see it in that 5x5 grid there. So this is kind of where the challenge was headed, to see if you can't come up with something like you did with Snake, right? So just to make it move across the page.
Right.
I'm concerned about your error, your memory issue. Can you tell me a little bit about that?
So the first code that I did was like a cord being plugged in, so it had 2 prongs and then the bulk of the plug-in going in, and it kept giving me a memory error. I don't know what would cause that. Maybe it's just, I mean, can it handle changing density every single shift?
Say that one more time. Density of what?
Like the light. So I had it started as 1s, then as it moved further into the wall, it went up to 2, and then 3, and then 4, and then 5, and then slowly up to 9. Would that cause it to have a memory error?
It depends on how many lines and how many characters you're doing it in. The microbit by itself, so the microbit unplugged from the Cyberbot, shouldn't have a problem with animating like that. But when it's plugged into the Cyberbot, we're noticing that we're maxing out around 150 or 130 lines of code. And it has to do with character usage, so you want to make really short variables. It's just a limitation of the microbit.
I've also, sorry, go ahead.
Go ahead. No. I was saying, if you're just using the microbit by itself, that shouldn't have been a problem. I wouldn't mind taking a look at the code that errored out, though, and maybe taking a look over it.
Yeah, I just kind of scrapped it.
Okay.
I've had issues before with like using some of my microbits where I'll get different error codes, and then I just reflash the microbit, like download the whatever's on the microbit site, and sometimes that takes care of it too.
Okay.
Yeah, I mean, I don't want to blame it on price, right? But this is a low barrier to entry because of its cost point. And with it comes some limitations, and they had to make some decisions. We've spoken to the BBC folks, the folks behind the microbit, and they had to decide, do I use a faster processor or a slow processor? Do I give you more memory or less memory? And in order to keep this thing at what the desired price point was, £5 back in 2015, 2016, in order to keep it at that point, they had to make certain limitations on memory and processor size, and we're really running up against the edges of its capabilities when we mount it to the Cyberbot chassis. So we're working with Parallax, and we're working with Microbit to try and extend that a little bit. And we figured out some tweaks. So if you guys have examples of code that fail, please send it our way. We'd love to talk through options and maybe even let you guys teach us something about what it is that you're doing in the classroom. So please share those.
All right, thank you. All right, no, Cheryl. Ashley isn't here. She did share her resources that she grabbed what she used her activity from. So
she's turning the 5x5 grid into a coordinate. Yep, and you're learning X and Y. Really great algebra connections here. Really great algebra.
Thanks. I love it. And I love that she's got a group working on this, and so I'm excited to hear what she's doing next. Yeah. Tommy, I don't think Tommy's here either. I read what Tommy says, and I have to tell you that she's got those freshman boys that loved the challenge. I just think that's so cool, that she's got kids. It reminds me of you, Dan, and how you were sharing how excited your learners are. So
what's cool, I'm sorry.
No.
What's really cool about it is every once in a while, more times than not really, they're working on something, they may be struggling with it, or whatever, and then all of a sudden it works and you'll hear, I got it, it's working, you know, and you can see this thing floating around all over the place, and it's just fun to watch. And they did it themselves and they figured it out. They problem solved.
So many light bulb moments in these classes, and it's fantastic. And it's all age levels too, right? We have some middle school experiences with this. We have high school experiences with this. And that's what the content's there for. So the stuff called Cyber Fundamentals, which is where programming with displays and animations comes from, it's not intended to be a year-long course, right? It's for those rainy day challenges. It's for those, I don't know what I want to do today, but I don't want to do what I did yesterday. So here's a new challenge. And I love that they're working through it. And even the previous example, right? Let's take the bot apart and make sure we know how everything goes back together. It creates that IKEA effect of ownership, and you built it, so you know what's holding this thing together. So it's just, I mean, you guys are doing great stuff, and I'm thankful for the opportunity to work with you all. It's great.
Then Tommy does have a quick question about cybersecurity lessons with her 8th grade bunch. And so she's going to look at your websites, Kayla. Aren't you glad you shared? And then does anyone else do a cybersecurity unit? If so, what do you use?
I actually have I didn't see like an answer spot on here, but I actually have another site that I can share. And Dan, I think you were part of this too, that CE for All, Cyber Education for All.
Yes.
Okay, so it's there was a group of us, about 25 of us, and we spent the week putting together cybersecurity lessons and resources. So the site, I can type in the site on the
I just gave it to you. I just gave you a column.
Okay, perfect. So that's the site, and if you go there, there's a tab that has resources on it, and it links all the resources that we came across. It shares our Google Drive for lessons that we created, and then there's a link to our Nearpod lessons as well that teachers can use. But there's a lot of variety of resources, and it's kind of a good starting point if people are looking to
go to the resources page.
Yep.
Okay.
And then there's just there's different links and resources and stuff on there.
Okay.
So.
Yeah, a lot of good stuff.
Mm-hmm.
Nice. Thank you.
When was that, Kayla? When did that happen?
This was in the summer of 2018.
Wow.
And my understanding is we'll be reconvening possibly this summer again to get some state curriculum approved.
Yeah.
That's cool.
So a lot of good stuff on there. Good starting point.
Thank you. Thanks for sharing that. All right. So Kayla, you dropped that in yours. Okay, I'll move it down and drop it into Tommy's too. Let's see. We have a lot of words. Kyle.
Hi, can you hear me?
I can.
Okay, cool.
So I think I opened yours earlier, but I'm not sure where it is. I'll just open it again because you can never have too many tabs open.
Right.
So what I did run through yours. It was very fun. And I love how yours, you say press A to make it go. And so thank you for telling me that.
Oh, that's great. I love that you didn't use their letters, that you made your own.
Yeah.
That's
yeah, they have I use the blocks just because I'm
Yep.
familiar with block programming. That's what I do with my kids and like Lego robotics and stuff. But I use the little show LED tab, and then to have it fade, I actually set a variable just so that it would fade within a loop.
Oh, here, I can pull up do you want the blocks or the?
The blocks is,
Yeah.
it's easy.
Okay.
Yeah, variables and loops, that's great.
Yeah, so I was trying to figure out a way to get it to have a letter up and then fade into something else, and so that was kind of the easiest way I found for that.
I wonder if you could do it with each letter in its own program, essentially. So
Yeah.
you would your on button press, you would start the K and then wait 500 and then start the Y, and then if they would bleed that way or not.
Sure, that's it.
But
That's a good thought.
So I like the button pressed. So I was curious if on your actual microbit, do the lights go off or not? So I'm counting, right? I see 255. Oh no, yeah, they do. So I'm doing the math in my head, right? So you start at 255 and then you do 5 times, drop by 50, which means hypothetically at the end of the loop,
At
I've
the end,
got my lights at 5.
yeah,
But then the next image turns everything off but the Y.
yes,
So that's where the lights get turned off. That's cool.
yeah. You can see it here at the end of this. The E does stay on until you
Yep.
were to press. Yeah.
So we can just sit and watch the Kyle
right.
go the rest of the day.
Kyle
It's
show.
kind of it's a Kyle show. It's kind of mesmerizing.
Amazing.
Thank you, Kyle. All right, so you were going to tell us what else you're doing.
Oh, sure. Yeah. Okay. So, like I said earlier, I haven't got a lot of experience teaching kids actual text-based programming, but I've been slowly, the format of my classroom is in rotations, small groups. And so one of the things I've been doing is with kind of one of the higher groups that's in the rotation is I'll slip some text-based robotics programming in. And so one of the things that I have is Lego Education has a integrated manufacturing set of lessons. And so I've got a couple of groups doing like CNC drawing machine or like a sorting machine, and included in those lessons are some Python text programming. So I have a couple groups doing that, and then we are starting some new after-school programs with some outside of school help. One of the programs is a video game programming, and so they'll use Construct 2, which I know is I think it's like slightly text, slightly block-based programming, and then there's another group coming to do some kind of base skills to starting a first Lego League team. So they'll be doing Spike Robotics, which is a brand new thing from Lego, kind of gender inclusive colors and some new parts that are a little simpler to build things quickly. And then they'll teach the kids on the EV3s the little bit more complex robots after that. So.
Wow. In that Cyber Fundamentals course, we've also got some EV3 content.
Yeah.
If something you're interested in. What ages are you working with? Did you say middle school rotations?
Yep, 6th through 8th grade.
I'd also encourage you, like we were talking with Dan, throw some Python challenges at them. Like I said, the content in there for Microbit has block and same activities with Python, so they can do it in block, and then they can see the relationships to how that same project will convert over to Python. If you're looking to get more, and it'll help you learn Python too. If Python's not your thing, I mean, I'm no rocket scientist, but I learned most of my computer science knowledge through what I do here at NYSERC. So,
right.
It's educational for you, the teacher too.
All right. So Adam, thank you, Kyle. Are you there, Adam? Yep, you are. Okay.
Can you guys hear me?
Yes.
Okay, I'm having a little trouble with my headphones. They keep cutting out. So, hey, I went ahead. I watched one of our other compatriots sketch this out when we were in the class. So I thought I was going to be so far ahead of everybody. And I started sketching it out and planning it out. And then I didn't quite leave myself enough time to do a really good job on actually writing the code. So I did get a couple of the frames done, but for the most part, I just basically have my sketches done. I had to look up a quick website on how to set up the arrays in the Python coding, just to kind of refresh my memory, but that was actually really easy. So yeah, that's just the website to, yep. And there's my sketch. So
Okay.
that's about how far I got.
And you were looking for the smile to move up and down?
Oh yeah. I had a plan that it was going to move up and down to a song.
Ooh.
I had really big dreams, but I think I should have gone for something a little bit more simple and just got it done.
It's okay. I think it sounds kind of fun. I love it.
Let me ask real quick. So help me understand the lighted up page. What were you using that for? Just to show you about how the arrays work and how the animation works?
Yeah,
Light it up.
that first array.
Yeah.
This one?
The second picture. Oh, sorry. I thought you were talking about my picture.
Which?
I know. So, yeah. So this page here.
Yeah, this reminded me how to do.
Okay.
It shows you how to set the the array led to on, and then how to set the intensity.
Yeah.
Just because I remembered something weird with the arrays, they start at 0, and I couldn't quite remember that when I was first thinking about it, like how to do the XY axis.
Yeah.
But they start at 0, so your highest one is only 4, but you have 5 rows. So I was trying to remember that, and I couldn't quite grasp it, so I had to do a little research on it.
Yeah.
But yeah, it was really simple once I looked it up.
Yeah, that's great. Yeah, so it gives us an origin, right? To use an algebra term, I have an origin, but it is not in the middle of the picture. It's the top left. So a student would tell you, but that means this is fourth quadrant, right? This should be positive negatives, but it's positive positives. So yeah, we're counting over and down from the top left. And then that third value is I for intensity, and it goes all the way from 0 to 9 also. So I can represent the whole grid with with three sets of 1 digits, which is really handy. So, and again, that plays to the memory issue we were talking about, right? So if I can condense this to just 1 digit, 0 to 9, that's less memory that's going to be taken up in the microbit, because if I had to represent it in 2 digits, that would take up more space. So it was purposeful on microbit's part to put this as a 5 by 5 grid with levels of intensity from 0 to 9. That really limited the size that they needed to set aside for the LEDs to light. Good deal.
Thanks.
I like the sketches too.
Yeah, thanks, Adam. And tell us what you've implemented.
I really haven't gotten very far on the implementations. I think it'd be a great ending project to some of the coding student interest groups. So I might just have to ask and see if I can teach my own student interest group in one of the schools, because I'm not a classroom teacher.
I know.
I travel around to the districts. So.
But I think it would be cool if you could get in, and it really has been exciting and rewarding to work with both the microbits and the cyberbots, just because of all the different things you can do with them and that physical aspect of it. So cool.
Exactly. Yep.
I'll put in a good word for you.
Thank you.
All right. And then Charnel was here, and I just saw she had to leave. So we will, she's implementing Boolean logic from NYSERC into her programming, and she has no questions. So I am just so excited by what everybody is doing, and I just can't wait to see what else you guys do. So now we're going to switch over to the new content for today, and the new content for today really is basically, we made you, or Chuck made you. I really blame Chuck for all of it. I would have never had the idea to give you a programming assignment. So it's okay, right, Chuck?
Yep.
And but the cyber fundamentals in the curriculum Canvas resources is where a lot of these resources came from, and where a lot of the teaching materials are. And so I've given you guys the link for that, and it is here. And as Chuck has been saying, at the top you have the make code and the Python, and they're the same activities, just different. One is with the
block and one's with the text. And
block, and one is with the text, yeah.
There's a couple more Python lessons because it's a little more capable with Python. I could do a little bit more with it. So you'll notice, I think there's a dozen lessons in the Python side, and there's only about 8 or so in the, so it's 13 on the Python side, and the make code, I think it goes down to 8. I think tug of war is the last lesson in the make code side. 7. So yeah, we can't quite do tug of war with block. Oh, there's a couple. There's tug of war. All right. So yeah, we've got all the way through 7, they're identical, and then 8 on, they change with the 2 programming environments.
And then one of the things that Chuck mentioned, I actually linked because the graphics here with the grid is linked on your agenda, so you can pull that up and just see it. But it does give you the nice grid and makes it so much easier to kind of visualize what's going on there.
So
And
this is yeah, this is part of another lesson that talks a little bit about you know, the conversion of binary to base 10, right? So clearly, yeah, so clearly the A isn't 14, 17, 31, 17, 17. But if I convert those base 10 values into binary, and you can use Google to do that, you can use, you know, Whiteboard and dry erase marker to do that. But if you convert 14 to 5 base 10 digits, I'm sorry, if you convert base 10 14 to 5 binary digits, you're going to get a 0, 1, 1, 1, 0. And if I convert that into pixels, then I light up the top row of my A. So I can represent the letter A in a series of base 10 digits, 14, 17, 31, 17, 17, provided I first convert them. I use a binary conversion, and there's Python methods to do that. So this is probably, this came from the make code side or the Python side?
it came from the make code side, or the Python side, sorry. It's this one right here, the 0, 0, the graphics.
Yeah, it's a really cool connection.
I just brought it in. I just uploaded it just because I wanted to make sure we could share that. And then I am always, so like Cyberbot, I'm like, oh man, there's no lessons there. It says it's coming soon. But then when you look at the resources, there's some really cool things here. Like the PowerPoint is excellent because it goes through and it gives you everything that, like what we did for the challenge, but then you can go on and so anybody who mentioned that their kids really like the challenges and you know, you're looking for different things for the challenges, it's even worded in the PowerPoint as challenges. And so yeah, this is kind of a fun one. I'm glad I clicked into the resources.
Another, I think I've mentioned it, though, learn. Can I grab the screen real quick?
Sure.
Where's my window? There it is. Oh, you're still. Escape. Put that there, and then share this right here. No, not that one. This one. Here we go. So this is Parallax's tutorial site. So it's called learn.parallax.com. And this is a lot of resources for educators on all of their robotics platforms, including Bobots if you have them, ShieldBot with Arduino if you have them. But then over here they've got Cyberbot. And this is some of the other content that we've helped them write to post on this site. But you've got all sorts of microbit introduction lessons. And then you've got activities with the Cyberbot. So this is where kind of the workshop grabbed its materials from. If you did the Whisker navigation, you can go through that here and learn all that. Then we've got some advanced projects using a remote control, using the ping ultrasonic distance sensor, using an infrared line follower kit. And then here is shortly where you're going to see some additional cybersecurity lessons. What we've done is we worked with Parallax last month. We spent a week in Rockland, California to work with them to develop lessons using the radio on microbit. And we've actually got some models of encryption where we're sending messages through encrypted networks using microbit, where a microbit is being remote controlling a cyberbot, and then we take it over with a malicious microbit. So learn.parallax.com. If you go to Cyberbot, bookmark it for what's here now, but then also come back. We're hoping that end of March, early April, that this cybersecurity content is going to be added here. But there's some, while we say coming soon, that's because we help Parallax put this content on this site. So take a look at this page too if you're looking for some Cyberbot lessons. And that's that. Julie, you're on mute.
Hey, I am on mute. We do have that linked on the resources too, so thanks for sharing that again, because, and I wasn't sure where those new lessons would show up, if they'd show up under the Cyberbot or not. So that's,
yeah, they're probably going to be under Cyberbot because we use a lot of Cyberbot in them.
okay. So did you want to touch on any more in the cyber fundamentals, lessons and the progression here or anything?
I think it's good. I wanted to see if I can't, my Google Drive is all, I resorted today at once by the last modified column, and then I tried to go back to the name column, and now every page is being sorted by last modified. It's really frustrating. But I wanted to show you what you can expect to see with microbit. I need to find the folder though. So where's microbit? Oh, I need to do some cleanup on this Google folder. Microbit. There it is. Microbit, develop, and oh man, that's it. Parallax. Parallax. I saw it. Parallax. There's the folder, and there's the image. Okay.
Did you want to share again?
Yep. Let me grab this and share this. So this is an image. We did this on whiteboard, and then they wrote over it with digital ink. So this is what the cybersecurity content is going to look like. It's going to include 4, 5, 6, 7, 8, 9, 10, 11 new lessons that's going to focus on introducing cybersecurity by way of microbit and Cyberbot. So we're going to first show how the computer talks to the microbit and that kind of dedicated channel. And then from that lesson, we're going to branch into 3 different paths. So it's almost going to be a choose your own adventure style. We're going to just talk about basic encryption using the microbit and Python to model encryption methods. Then the middle one, you see MB plus MB. So with 2 microbits, we're going to introduce radio basics. So communication using the radio feature of both Python and the microbit. And then the third option from the first lesson is how to work with strings and dictionaries and error handling. This is a really cool lesson on kind of solving more complex problems, because if I build error handling into my programs, I'm able to learn how to debug more efficiently. Microbit is a hog when it comes to debugging, right? Because you got to wait for the message to scroll across that screen. But if I can build error handling into my program, then I can work quicker and get through problems easier. And then the third level of content, I'm going to use encryption and radio to do some encryption via radio, so some wireless encryption on the fly, and microbit to microbit. These devices are going to be encrypting messages, both encrypting and decrypting. We're going to do a little bit of radio nav control, so this is remote control of another Cyberbot with a microbit. And this is really where it's going to spread off into some of the more advanced cybersecurity stuff. So we're going to do some brute force examples of breaking signals. We're going to do key exchange and talk about some cryptographic methods that use public key encryption. We're going to move through some simple attacks like man in the middle and denial of service. Well, then denial of service is so important, it's going to have its own lesson. And then finally, a replay attack. So we're going to set up a network of microbits, and we're going to show how messages can be sent across networks. And then in that echoing of message from one microbit to another, I can have a malicious actor in there that either takes over or, just simply changes things so that the message that gets through was not the message that was intended. So just to give you an idea, this is the stuff that we're working on. And of these 12, 8 or 9 are written. We're just waiting for formatting and templating and graphics. And then this stuff's all going to be posted on the Learn Parallax forum.
That's exciting.
Really cool.
And when is the expected launch?
So the content is in draft form. We're waiting for templating and graphics and stuff. So before the end of the school year, I wish I could say, March or April, but I'm tempted to say late March, early April. But I don't want you to, string me up and draw a quarter if it's not there on time. So
Well,
sometime.
the last webinar is the end of March, and so after that, Chuck, you're probably safe.
I'll know, I'll know more then for sure.
Thank you. I'm glad. That's really nice to see the plans there, because it'll help us as we're moving forward. All right. So popping back to the agenda. So then really that wraps up the new content, and we don't have any going out and finding anything or anything today. It's just kind of share what you did, and we have a new challenge from Chuck. So do you want to talk about it, Chuck?
Let me see. It's been a while.
We should never plan this far in advance.
Oh, yeah. So hopefully you have your Cyberbot still built, because this is going to be some programming on the Cyberbot. So if you have your navigational programs from the workshop, where before you even install Whiskers or any other circuits, just the basic bot navigating around the floor, forward, back, left, and right. The goal here is to get a bot that goes straight forward, straight backwards, and makes accurate lefts and accurate right 90-degree turns. So that's the first part of the challenge. And kind of the conversation from that is going to be, how did you adjust the code? If you have a bot that curves to the right or curves to the left, how did you adjust the code to compensate for that shift? Second part here is what would you get if you were to cut the rubber O-ring on the wheel, and the answer is a circumference, right? So I have these science to math connections that I can make through robotics. So now that I know that O-ring becomes a circumference, and if I were to cut it, it's now a linear distance. Can you make the bot travel one circumference and verify that a circumference equals the distance around the circle? So that's the second and third statements there. And then how far, so it's already there. So that's it. How far is it going to travel? What is a circumference in linear distance? So straighten the straights so that you can verify one circumference forward or one circumference back. Piece of cake, right?
They're so quiet. All right. So you have another month or so to do the challenge. And as always, you can send emails or whatever if you need to. And then report your challenge in the reflection sheet, and also what you did. So our last webinar will be Tuesday, March 24th. And we will recap on that and have a little bit more new content. And hopefully, if you guys have any questions or anything, we'll be able to answer them. And thanks so much for coming today. I appreciate it.
We are almost there. You guys get a thaw soon.
Sorry.
I hope you guys get a thaw soon.
Yeah.
Thanks.
You too.